Nobody wants to do it, but this is something you have to do in 8th grade. Yes or no? Okay. So how can we do it? The first thing I would do is you can do it the old-fashioned way. You can divide the numerator and the denominator. What's the numerator? Top number. What's the denominator, guys? Bottom number. Now you can find their GCF, or how about we just do it the way that I was taught back as a kid? I don't want to sit here and take forever. Guys, can you think of a number that we can divide top and bottom by? Just, right? Which one can we divide 36 and 40 by? And you go, hey, I can divide both of these by 4. Go ahead and do that because it's going to make it smaller. And then after you do it, just do another little quick check of, can I divide the 9 and the 10 by the same number? I can't do that. Guess what? We have simplified my fraction. Now, by sheer accident, we have actually found the greatest common factor of 36 and 40. Now, another way that you could do it, they're both even, yes? So what's that mean? We can divide them by what? 2. And then that would get me 18 over 20. Now, are these still both even? It's another way of getting it down to 9 over 10. Do I really care if you take the time to find the GCF of both of these numbers, the 36 and 40, and then divide it? Not really. If it takes you 5 minutes to find the GCF, that's not going to do you very much to speed things up, is it? In fact, it's going to make you scared that you haven't found the GCF. So yeah, this is the old school of like, can you find a number that you can divide top and bottom by? Your numerator and your denominator. Now that's your style. Would you like to see one more style that might work? If you're like, Mr. Tate, without a calculator, I'm sunk. Here it is right here. This is the end of this one right here. 54/60th using what? Prime factorization. We're going to have 54 right here, and we're going to do a factor tree. Guys, didn't we do 54, the prime factorization on the bell ringer? 6 times what? 9, and then 2 and 3, those are primes. What's the 9 going to get down to? 3 and 3. So do this for me. Right, 54/60th as a fraction right over here. And if you don't mind, just write your prime factors for 54 right here on the top line right here. We're just going to haul them over here. Now this takes a little while, but if you're pretty good at finding your prime factors, it really doesn't take that long. So let's do 60. 6 times what? 10. 2 and 3, 2 and 5. Now you want to rewrite these factors right here next to 60, but make sure that you don't take forever. Order them from, least to greatest. Now I need us to add on one other thing. It says by using prime factorization. Got it, boss. We got it right there. Now it says cancel your common factors. What's 2 divided by 2? What's 2 divided by 2? 1. Hey, can this 3 right here be divided by that 3 right there? Yeah? And now here's the last thing that we got to do. I need you to add it on right over here. Multiply leftover numbers. What do you mean by multiply the leftover numbers? Well, we still have numbers up on top. Technically, I could put 1s up there from where we did 2 divided by 2, and I can make that a 1, but there's no need because what do we have right here? 3 and what? 3. So what's 3 times 3? 9. What's 2 times 5? 10. Now, it is just pure coincidence that this is 9/10 and that one's 9/10 right there. But what we have made is we've made equivalent fractions. This 9/10 is a simplified version of this 54 over 60. It's just a lot easier to work with when you're in higher level math, and that's what we've done. Okay? Do I care how we simplify a fraction? I don't care how. I just need you to be able to do that. Okay? So try this new method if you need to, and let me know how it goes.